Hi and welcome to the first of our webinar series, Connection Regardless of Location. This session will focus on the in-building coverage. My name is Sam Dilley and your speaker today will be Stuart Stevens, one of our Senior Systems Engineer here at Axell Wireless. We've got a very interesting webinar today, but before we start I have a few housekeeping points to make. During the webinar you'll be placed on mute to avoid any feedback and to ensure we finish on time today. If you have any questions for Stuart, please send them via the chat option, which you can see on the right-hand side of your screen. We will get through as many as we can at the end of the webinar. Okay, let's get started. Over to you, Stuart.
Thank you very much, Sam. Hello, everybody. Welcome to our in-building coverage webinar. Going to go through a few slides with you and hopefully go over the topic for today. The agenda for the next half an hour will be a brief introduction of Axell Wireless. We're going to cover why in-building coverage, go over some solutions, and finally a case study of a big system we did a couple of years ago, and a Q&A session. So, introduction. Who are we? Axell Wireless is a global developer and manufacturer of DAS and wireless coverage systems. Main HQ is in the United Kingdom in Chesham. We have office globally. We are part of Cobham PLC, which is a technically huge company with a revenue of $3 billion. We've been providing cellular, public safety and railway applications for over 40 years, giving us a very big insight into this industry. We really do focus on quality and technology intervention and innovation. We have customers in over 150 countries, including 170 mobile operators across the globe. This gives us a unique view because we see globally what's happening in the market, not just in individual companies and individual countries, which allows us to come up with ideas which we see and can take from other parts of the globe to come up with better solutions, more cost efficient and better performance. We do this via 16 offices worldwide and we have over 250 employees, and that is still growing daily. The latest ABI research says that Axell Wireless is #1 for innovation, because this is mainly due to our digital portfolio and different ways of looking at in-building applications. We are ranked #3 globally overall, and our market share continues to grow, and this year is looking like to be a record-breaking year for Axell. So, what we're actually here for, why in-building coverage? We now see that 80% of mobile phone usage comes from indoors, not from historically where you would say mobile phones for when you're out walking or outside. Nowadays it's office people sat at their desks or at home using their mobile device. More and more people are not actually picking up a fixed land phone, they're just grabbing their phone because all your contacts and everything are there. Another reason we have this is because you want this convenience. The latest building technologies and different types of applications are shielding the wireless signal from getting in. We've seen the latest windows, for example, which are thermally cool and will thermally heat the building, but also won't let the penetration in. We also see that dominant cell definitions from different outdoor macro layers can sometimes have multiple cells from inside from out, causing disturbance and having problems with calls dropping, phones frequency between cells, and sometimes there may not be the capacity there required. If you think of high-rise buildings and big office apartments, these are getting taller and taller as more and more different technology comes. The problem is that antenna signals are normally pointed downwards and not upwards, and there's only a defined length that these signals can go before they start to drop and cause out. So if you have a very tall building, you'll probably find there isn't any coverage up there. There is a massive demand for capacity now. The buzzword is a tsunami, because the amount of data people need is becoming more and more. I mean, people have not only a mobile phone, they have tablets, we have the new 4G, people want constant updates and different web applications and different apps that require data. We're also seeing that many employees are using your bring your own device scheme. So rather than having to be signed to one phone, you now get 2 smartphones, one personal and one for your work application. If you actually look, the research shows that the actual in-building growth has doubled in the last 5 years. And active solutions, which is mainly what Axell Wireless specialise in, has accelerated rapidly. There's always been small passive solutions, but we've seen active as a real market grower, which is also part of the reason why Axell has grown so sufficiently over the last 5 years with it. So if we go back to our topic of why in building coverage, we kind of have 3 areas we kind of think about. One, for the tenant and resident of the apartment block. If you're spending a lot of money on a house or a building, you expect mobile phone coverage. We're sort of seeing that people are thinking of it as more like when you go into a house and you have a plug socket or a fixed landline, people expect their phone to work. Especially if you're in like the centre of the UK here in London, if you're going to spend a lot of money on an apartment block or you're going to work from home as part of your business, you need the communication. So uninterrupted connection is a key area. Also with this buy your own device policy, there's no point having this unless you have connection to it. And also companies also want to utilise the network and promote their products and services for it. For the mobile phone operator, or the MNO, customer satisfaction is key, because if the user can't use their handset, they will maybe change to a different operator who may have some coverage in that area. And also increased revenue and premium standards on roaming customers. So if you take an in-building example of an airport, huge numbers of international roamers coming in. The operators want to grab those customers as soon as they can when they get off the plane. For the property owner, great customer satisfaction as well. Again, utilise the network to communicate with their tenants on maintenance, update, and also it makes leasing that property much more favourable and also much more amenable for the services available. So, how do we get this solution to work in these buildings? We see 4 potential ways of providing an in-building coverage. A passive DAS, or a distributed antenna system. This is very historical. I've been installing those for probably over 10 to 15 years. Remote radio heads, a very new and exciting way of doing in-building coverage. Optical DAS, again, this is what Axell Wireless specialises in. And also off-air repeaters, which we're going to cover because they're a bit, although work very well, there is some legals around them. So, start off with, we're going to look at passive DAS systems. Passive DAS is normally fed from an MNO's main BTSs, which are placed in a building. These are combined and then put out via a leaky feeder cable system throughout a building. These are normally used in smaller, low capacity applications. A small office building, maybe a small shopping centre. The main advantages are they are very low cost. It's standard material, coaxial splitters, antennas, and they're wide band. It doesn't matter what the operators do or what technologies go on, they can be passed through the system. The problem now is with LTE at 2600 megs. The loss of the cable becomes an issue and the performance of these systems can be limited. The challenges we see with this and the thing is it's difficult to adjust sectors to add the capacity. You can't have sector A go into the left wing and sector B go into the right wing, because it's all going to pass through the same common interpoint. And it's also limited ability to scale due to the losses of the cable. If the shopping centre grows or the office block grows, they want to add another story or another building comes in, you may run out of power. You can't instantly turn up the base station to achieve your coverage. And another hot topic at the moment is PIM, high power PIM combining. Historically, for 9, 1800 and 2100 megahertz, you may be able to have got away with a minus 140 dBc PIM requirement. And now you're looking at 160 dBc as a minimum for a good LTE service. This is highly challenging, and the reason why Axell is actually moving away from passive DASs, because to achieve that level, maintain the system, test the system, meet those standards is challenging. And actually, unfortunately with that, it's all down to labour costs, and that's one of the highest costs you're going to have. Remote radio heads or small cells, these are a good option for a single operator deployment, and what if you phone up and you don't have coverage in your home, something they will probably deploy to get you coverage for a building. They can be installed very near to the antenna. In fact, some of the newer ones actually have the antenna as part of the unit. They're very smart, split of base station components with processing. And there's also a very good network transparency, which means you can detect if there's a problem. These literally are part of the MNO's network. So the same as they can detect if there is a problem outside, they can also detect there's a problem inside. The challenges which we see for remote radio heads is that it's a single box for each band, and this always operates in the operators having many units to be installed. So if we think of a football stadium, if you're up on the gantry and you have, say you have 5 bands, you may have a dual band for 2 of the frequencies, you're still probably looking at 3 boxes. This is for one operator. If you had 2 operators, that's 6 boxes. If you had 4 operators, you could be thinking of 12 boxes. If let's go back and say there's maybe 6 boxes, you still then have to combine these somehow. So you're still going to have a multi-operator combiner, and then we go back to size, power performance, and PIM requirements. Another thing which kind of gets overlooked is the inability to simulcast, and this really reduces the trunking efficiency that is available there. We've covered the complex combining and the high levels of power and space required. Each of those remote radio heads need a power supply, some sort of means of powering them. If you have all those units up, you could be looking at quite a substantial electricity bill just to run the units. They're not power efficient. So optical DAS, again, this is mainly where Axell's key and history is. We take the BTSs, we combine them at a low power, which gets rid of the PIM problem. We then go to an optical unit, and then we then use dark fibre, single mode, to distribute around the building or shopping centre to a remote unit. This unit is all bands up to 5. We now offer 8 bands in 2 boxes to have a full MIMO technology. This gives a very small footprint for multi-operators. It also allows you to have one box that does everything. Also, because of the very, very good noise figure, this gives you a much higher throughput in the uplink. And on new systems, it's all about throughput. How much capacity and how much throughput can you get out of the system? So from an Axell view, this is what we see as the main advantages of an optical DAS. All bands and operators in one box for a small footprint and low power consumption. One box, one power supply, much lower costs of running. due to the, for give you an example of maybe our multi-band combiner has an uplink noise figure of just 3 dB. This gives you a much higher data throughput on all the frequency bands available. Individual sector patterns for each band also, you can move the sector patterns back. So again, if we go back to a football stadium, you could have one sector narrowly pointing to a few members of people in the bowl to give a high capacity bowl unit. This is also where the BTS Hotel concept comes from, which really does optimize the copex and optex, and it's also easily expandable for if you have a different antenna where you need to have a slight shadow area, you could couple it in, and if you needed to add another band or another unit, we could do it. So if we look at the bigger picture and go through what units offer you what, again, these are open for debates, we know. But a low noise figure and a low path loss, we think remote radio heads and optical DASs are the key strongest computer for it. There's only one way of doing a simulcast, and that's through optical DAS. A single unit and a single cabinet for all bands and all operators. Active DAS monitoring. Only remote radio heads and optical DAS offer this for a complete system. You can get cable fault monitors for passive DAS. I have seen some monitoring systems, but they're not part of the operator's network. They're not constantly monitoring it. PIM issues, again, not so much for old 2G, 3 systems, but very, very, very applicable on 4G systems. Support of multiple operators, this is where passive DAS again comes into its own because it can support multiple operators and optical DAS, but remote radio head tends fall over here. And high energy efficiency, well, that's not actually applicable on passive DASs, but we are very, very efficient on an optical DAS system. We covered this briefly on the other side, and that's the BTS Hotel. The BTS Hotel has been around now for a number of years, and it's designed to have a single location where all the MNO's equipment is placed. This really does considerably reduce the OPEX and CAPEX and space saving on where your BTS equipment is. It can be a controlled environment from a central location. Having been a person who has worked on these sites, it also means there's just one key and one room to go to be able to fix the units. Everybody knows where to go to look at the problems. All the units can be monitored and looked after from a central case. What this means and how they work is you have a location where there could be an external macro site which you're coupling some power off from. It could be a dedicated BTS unit, but it's one location. You then run dark fiber to a single building, a number of buildings. We're seeing more and more where if they're going to build a 90,000-seater football stadium, there's also going to be a hotel in that facility because after the event or concert people are going to want to go to it. There's also going to be an opportunity for a shopping centre and outlets, and that's where they're going to want to put the units to. The OMU and the main principle is that we always convert from high power down to low power using an OMU, or what we call the optical master unit, to a number of fibre thread remote units. This is a particular overview of a system architecture. So you have a baseband base station, from high power attenuators down to an optical master unit. There's always some sort of POI deployed on how the MNOs are going to combine their units together, different bands, different levels. This then will go down to the optical master unit, and then from here to a number of remote units. Depending on the system, or depending on the number of remote units you need. Some buildings require high power units, maybe 3 or 4 of them, and other environments go for a low power unit, maybe a high number of them because you want to highly put where the capacity is. This is the Axell Wireless system architecture of how we do this. So from the base station, where we take up to plus 46 dBm on some of the newer high power LTE sessions, we have to have a very high quality, very high power, 161 dBc proved attenuator. This then feeds what we use as an APOI, which is an active POI, which balances all the services from all the operators to ensure a distributed, clear, balanced system. This is then fed to what we call the multi-service combiner. This combines the 900, the 800, the 2G, the 3G, the 826 4G systems to common TX-RX ports, which can then be distributed evenly across the building through various different locations, which is then fed to a number of fiber optic remote units. We offer two different types. We call them the MBF 40, which is the high power. It's called the 40 because it goes plus 40 dBm composite power to mimic almost base station performance. And we have the MBF 20, which is the low power unit, again designed for smaller systems and smaller buildings. MIMO is another big topic which is we're seeing a lot of deployment in some countries, other countries not so deployment of it. MIMO is multi-in, multi-out. It allows two signals of units to come in, and it really, really highly increases your throughput to give much higher capacity. We have had full 70 megabits per second on a 10 megs wide MIMO systems running in a number of locations. We've even now done MIMO in underground locations on leaky feeder and antennas. So we see MIMO as very much a way of really increasing the capacity. We do it in different ways. We have two fiber optic links to a single box to have a 2x2 MIMO with a 2G, 3G system there. Or we also have two independent boxes to have 2x2. The key to MIMO is two paths, two technologies. But in a building, you could use maybe a DAS system and a remote radio head for one operator to maybe have a hotspot. Hotspots where you have standard coverage in the building, and then maybe in a conference center you have this MIMO in that area where there could be events and required coverage. So an example would be two fibers to one box with two antennas, a clean solution, and because our components are modular, we can expand it as your network expands. The key is it's very much part of the network principles. Need to talk about off-air repeaters. Off-air repeaters are a very cheap and very easy way of getting in-building coverage because it takes a signal that's already there and distributes it into the building. There's always a DAS, which could be a passive DAS inside. Again, we have to think about the passive requirements that we've already covered, but it's a way of doing it. This solution is very suitable for small buildings, car parks, and smaller locations where signal is a problem. But we have to remember that we are taking the capacity from the existing outdoor macro layer. If there is no capacity there, there will be no capacity in the building. And if you don't plan this, you can actually cause more problems than solutions. So although off-air repeaters, and we do sell a lot of them, is a very good solution, planning and key of it is applicable. We only use digital solutions, so we only go to multi-operator, multi-band, full selectivity. We have an automatic gain setup and thing, and we also have isolation measurements. Unlike old repeaters of 5-10 years ago, new digital repeaters will never oscillate. They will never take down the MNO's network. In fact, the Axell repeaters, if they oscillate too much or find a problem, they actually shut themselves off and send an alarm to say there's a problem, rather than causing big problems to the existing macro layer, which could affect a huge number of people. We use a hybrid method between hybrid of band select and channel selections for frequency hopping as well, but with very sharp digital filters. This means that only the MNOs who want to use that repeater are affected. They are not these broadband devices that can be bought off the internet to just give you coverage inside a building. Whether you're doing it via an optical DAS or an off-air repeater, one thing is key is management. These units have to be part of the MNO's network. There's no point having them causing problems. So we really do push to make sure, and we have some very nice web GUI-based browsers which enable you to, as your network changes, your repeaters or optical DAS changes too. It becomes part of your core network. So let's just go through a quick case study. This is the Shard in London. I don't know if you have seen it. Well, if you live in the UK, you can't miss it. It's now one of Europe's tallest buildings. London is on the rise. It's going upwards because they've run out of space. And the Shard is a staggering 244 meters high. It's home to a couple of top-flight restaurants and the 5-star Shangri-La Hotel and high-end residential apartment blocks, which means they have everything there. The Shard gets narrower as it heads to the skies, but even so, it has an 18,000 square foot viewing platform, and that's capable of housing just over 200 people just on that one platform. And as you can imagine, getting a good quality in-building system into this was no easy task and faced a number of engineering challenges. So, the solution, we provided an industrial leading fibre-fed distributed antenna system which has been greatly admired and has proved very successful. We did a BTS Hotel in the basement of the building where a controlled room and easy access was available, because then we can monitor and control the systems through all the units, including the hotel and the actual residential apartments. For a building that high, we had to install 23 fibre-fed repeaters, but this is fed off 17 sectors. So in some areas, it was one sector per repeater, just because the number of people that could be in that area. The system also has designed to be expanded and future-proofed if 4G and different MIMO applications are required. Benefits of this is we now have a 95% coverage on all levels of the buildings. In fact, we actually surpassed that specification and it was almost 99%. It's a multi-band, multi-operator. Thus, it doesn't matter what MNO is there, they can pass through the system. And also, the disruption from outside sales was immediately eliminated because of the pure dominance of the in-building DAS system. So although it's a big glass building, because of the dominance for the in-building coverage, the outside sectors are ignored. And there was very big savings on the COPEX and optics, which the MNOs were very beneficial from. Thank you very much for listening. I hope you found it informative, and I'll pass you back over to Sam, who may have some questions.
Thanks, Stuart, and thank you all for listening. We've had some good questions come in, so I'll get right on to them. The first one I've got is it legal to install an off-air repeater?
It's a good question, and yes, they are legal to install, but they have to be owned by an MNO. The MNOs pay huge sums of money to the governments to own the frequency spectrum, so they own the frequencies. So I haven't found anywhere else where this is a thing, so I believe all countries are the same. I've worked in a lot of countries around the world, so you can install them, but the MNO or a mobile operator has to take ownership of that repeater. In the UK, for example, it's illegal to go and buy an off-air repeater and install it yourself, but if you contact the MNOs, then they can license it for you.
Great, thank you. The second question I've got is, how many clients can be connected to a base station?
That's a very good question. Are we talking clients as in number of users on that one base station, or?
Let's assume so.
Okay. So depending on, we normally say 2,000 people per sector. So it will depend on the number of sectors on that base station. So if it's a single sector base station, it's around 2,000 users.
Okay, great. Thank you. And next one is, can you overlay a new 4G system onto an existing 2G or 3G system?
Yes, you can. Again, the problem is with PIM issues, so you may have to upgrade some of your infrastructure to pass the 4G system to allow for the 160 dBc intermods. But yes, if you have a 2G, 3G system, this could be from any supplier. You could overlay different fiber maybe on top of it and combine the new and old together. So yes, this is possible.
Okay, that's great. Right, I think we'll leave it there. Thank you all for joining us on the webinar, and if you have any further questions, then please don't hesitate to contact us directly.